questions 1 through 10 on the 2015 grade 12 AMC 12B. What is the value of 2 minus negative 2 to the power of negative 2? Well, when you have negative in the exponent, you flip it, bring it into the denominator like that. And then negative 2 to the power of 2 is 4. So this is just 2 minus 1/4. Get a common denominator, and we get 7 over 4. So number 1, the answer is C. Marie does 3 equally time-consuming tasks in a row without taking breaks. She begins the first task at 1 p.m., finishes the second task at 2:40 p.m. When does she finish the third task? So 1 p.m. is when this all starts for her, and she will finish a first task, then finish a second task, and then finish a third task. So they're saying that she finishes the second task at 2:40. Now the tasks take an equal amount of time. So for 1 to 2:40 was 2 tasks, which is what? 60 plus 40, 100 minutes for 2 tasks. So each task obviously took 50 minutes since they all take the same amount of time. So the first task she finished at 1:50. And therefore, since it's 50-50-50, the third task will finish 50 minutes after this, which is 3:30. And therefore, number 2, the answer is B. Isaac has written down one integer 2 times and another integer 3 times. The sum of the 5 numbers is 100, and one of them is 28. What is the other number? So I have x, x, y, y, and y, and that sum is 100. So 2x plus 3y is 100. Now I have to decide which one is 28. Is it y or is it x? Well, let's go with the y. So that means 2x plus 3 times 28 is 100. So 2x is going to be 100 minus 3 times 28. So that's going to be 16. And therefore x is 8. So they're both integers. It works out. So number 3, the answer is A. David, Hikmet, Jack, Marta, Rand, and Todd were in a 12-person race with 6 other people. Rand finishes 6 places ahead of Hikmet. Marta finished 1 place behind Jack. David finishes 2 places behind Hikmet. Jack finished 2 places behind Todd. Todd finished 1 place behind Rand. Marta finished in 6th place. Who finished in 8th place? All right, so let's go through all of these. Rand finishes 6 places ahead of Hikmet. So if Hikmet is here, Rand is here, and this is 6. Marta finished 1 place behind Jack, so Marta and Jack, there's 1 place. David finishes 2 places behind Hikmet, so this is 2. Jack finishes 2 places ahead of behind Todd, so that's 2. Todd finishes 1 place behind Rand. Okay, so now I know where M, J, and T go. It's going to be M, J, and T. So this is 1, this is 2, and this is 1. And since this was 6, and this is 1, 2, 3, 4, that means this is 2. So then they're saying Marta finished in 6th place. So Marta, who's right here, she finishes in 6th place. Who finished in 8th? Well, Hikmet, who's 2 places behind her, he would be in 8th. So that means the answer to number 4 is B. The Tigers beat the Sharks 2 out of the first 3 times they played. Then they played N more games. Then the Sharks ended up winning at least 95% of all the games played. What is the minimum possible value for N? All right, so we have the Tigers and we have the Sharks. And initially, in the first 3 games, it was 2-1. That's the score. So then later, we have to figure out how do we get at least 95% average for the Sharks. So the average, well, we have to figure out the minimum possible value for N. So what I did is I just went with the answer choices. So let's start with 35. Let's see. So if N is 35, then that means that we have 35 more games. This was 3 games, and the outcome is 2-1. So 35 games, we have to have some sort of an outcome. And the average will be the total number of games won by S. So I'll just put that as S. So I don't know how many games. But we divide, obviously, by 3 plus 35, which is 38. And we want that to be at least 95. So at least 95, so greater than or equal to 95. Like that. So if you do this math, you find out that S is equal to 36.1, greater than or equal to. Well, that's not possible because there's only 35 games, so you can't win 36 games out of 35. So that one's out. So let's do the exact same thing, but this time with 37. That's the next answer choice. Now this number of wins for the Sharks would be 3 plus 37, which is 40, and we want that to be greater than 95. And when you do that, you get exactly 38. Is it possible for that to happen? Well, yes, because if this is 0 and this is 37, 1 plus 37 is exactly 38. So this is possible. The previous one, even if you had 0 and 35, if you added that, it would just be 36, 36.0. And we wanted 36.1, which is not possible. So the first time this is possible in the answer choices is 37, and that therefore is the minimum value of n. Maybe some of these work, possibly, but 37 is the minimum. So number 5, the answer is B. Back in 1930, Tilly had to memorize her multiplication facts from 0 times 0 through 12 times 12. The multiplication table she was given had rows and columns labeled with factors, and the products formed the body of the table. To the nearest hundredth, what fraction of the numbers in the body of the table are odd? All right, so I'm not going to draw the whole table, but I'm just going to draw sort of one row, I guess. And obviously that's going from 0 to 12. And then same thing on this side. And I'm sure you guys remember this from way back in elementary school. Now, first of all, how many are there? Well, there's 13 and 13, right? This should be a 12. 0 to 12 and then 0 to 12. So that means there's 13 times 13 numbers, which is 169. When you complete this entire table, there'll be 169 numbers in the table. Now we want to know how many of those 169 are odd. Well, it's a multiplication table, so every number in this table is some number from here multiplied by some number from here. So we want two numbers, say p times q, to be an odd number. And the only way that happens is if p is odd and q is odd. Because if they're both even, the result will be even. So like 4 times 6 is 24. If one is odd and one is even, like say 5 times 4, this is odd, of course, and this is even, the result, interestingly, is even. So the only way to get odd is both numbers have to be odd. So that means I've got something like, say, 7 times 5, which is, of course, 35, which is odd. So how do I get this scenario? Well, how many odd numbers are there, first of all? 1, 2, 3, 4, 5, 6. So there's 6 possible choices for a P. And for a Q, 1, 2, 3, 4, 5, 6. Also 6. So 6 possible choices for Q and P. So that means there's 36 possible ways of getting an odd number. 36 out of the 169. So if we want to figure out the fraction, it would be 36 over 169. And this is approximately 0.2, 0.21, I think. And number 6, therefore, the answer is A. A regular 15 gon has L lines of symmetry. What is, and the smallest positive angle for which it has a rotational symmetry is R degrees. What is L plus R? What we can do is first just look at something a little bit easier. Instead of a 15 gon, I'm not going to write that out, just let's say six sides is a little bit easier to draw and a little bit easier to explain. So let's say we have a six-sided shape, hexagon. Now let's talk about the first thing, lines of symmetry. Well, if this was perfectly drawn, there's one line of symmetry. There's another line. There's another line. That's 3 so far. And if you cut it down the middle like that, then that's a 4th line, a 5th line, and a 6th line. So if this was perfectly drawn, you would see that these are definitely lines of symmetry, and there's 6 of them. So 6 lines. So L in this case is 6. This is a 6-gon, also known as a hexagon, and L is 6. And if you do that for any number like 5-gon, 7-gon, you'll see that L will always be 6. Or L will always be the same as this number right here, N, for any n-gon. Now let's talk about the angles here. All right. Now the angle, first of all, what do they mean when they say rotational symmetry? Well, let's say I took this point right here and rotated it so that it landed there. If I did that, it basically would become the same shape again, right? And they're asking how many degrees did that have to rotate? Well, it had to rotate from there to there. How do I figure that out? Well, the full rotation all the way around is 360 degrees, correct? And you divide by, in this case, the number of sides, which is 6. So 360 divided by 6 is 60 degrees. So in this particular case, R would be 60. So in this, L plus R would be 66. All right. So now we get to our 15-gon, and we pretty much do the exact same thing. L, well, that's easy. That's just 15. It's the same as that. But then R is going to be 360 divided by 15. And 360 divided by 15 is 24. So now L plus R is 15 plus 24, which is 39. So number 7, the answer is D. What is the value of 625 to the power of log 2015 to the base 5, all to the power of a quarter? 625 log of 2015 to the base 5, all to the power of a quarter. All right, so what do we do now? Well, one thing is convert this 625 to a power of 5, and that's 5 to the power of 4. And that will help us, I hope. And now what we can do is just use basic exponent laws, where if you have, say, 5 to the power of A to the power of B to the power of C, this just becomes 5 to the power of A times B times C, right? You're just multiplying, basically. So using that fact, this just becomes 4 times the log of 2015 to the base 5 times a quarter, like that. And the 4 and the quarter cancel themselves out, so all you're left with is just log of 2015 to the base 5 as the exponent, and the base is 5. Now at this point, what do you do? Well, it would be nice if this could be a power of 5, but it's not. So since it's not, I'll just call it a power of 5. I'll say 2015 is some 5 to some n. I don't know what it is, but let's just say. So that means this becomes 5 to the n. I just substituted 2015 as 5 to the power of n. Now the n comes out front using log rules. And then log of 5 to the base 5, that's just 1. So this just becomes 5 to the power of n. Well, 5 to the power of n is 2015. So there we go. It's an interesting little question. Number 8, the answer is D. Larry and Julius are playing a game, taking turns throwing a ball at a bottle sitting on the ledge. Larry throws first. The winner is the first person to knock off the bottle off the ledge. At each turn, the probability that a person knocks the bottle off the ledge is a half, independently of what happened before. What is the probability that Larry wins the game? So we have Larry and we have Julius. So let's make a table carefully. Win, loss, win, loss. So let's talk about this. Larry goes first. So if he knocks, he has a 1/2 probability of winning, right? According to the question. So he can win if right off the bat he knocks it off. Okay. But it keeps going. If he doesn't, that means he loses. Okay. If he loses, then Julius gets a turn. Julius could win with a probability of a half, lose with a probability of half. We want Larry to win. So that means this is the first possible way. The next possible way is if he lost on the first turn, and then Julius lost also, right? And then on the next time, Larry wins. So do you see what happened there? Let's recap. The very first time he knocks it off, he wins. So that's why we have a half there. But if that doesn't happen, if he were to actually lose, then we get into the second scenario, which is right here. The second scenario is he loses the first time. That's why we have a half. Then Julius loses, because we don't want Julius to win, so there's a half there. And then finally, he wins the second time. He throws the ball at the bottle. Okay, then we just keep going. Now we have a scenario, let's say, if when he went again, he again lost. Okay, so let's do that whole thing now. He loses here, a half. Julius loses here, a half again. He loses again, a half. Julius has to lose again, so another half. And then finally, on the third time, Larry wins. So a half again. And these are all multiplications. And as you can see, this just keeps going. So this is an infinite series. It's a half times, plus an eighth plus a 32nd plus so on. And in an infinite geometric series, the sum is a cool little formula, a over 1 minus r, where a is the first term and r is the common ratio. So a is the first term, which is a half, so a goes here, and r is the common ratio. How do you find the common ratio? Just take the second term and divide it by the first term. So it would be r would be 1/8 divided by a half, which is 1 over 8, cross multiply, invert and multiply, 2 over 1, which is a quarter. So that's my r. So I have a half over 1 minus a quarter, which is 3 over 4. And then invert and multiply, and you get 4 over 3. And that is 4 over 6, which is 2/3. And there we go. So number 9, the answer is C. How many non-congruent integer-sided triangles with positive area and perimeter less than 15 are neither equilateral, isosceles, nor right triangles? So we have some triangle, and let's just say it has 3 sides, A, B, and C, and let's say A is greater than B is greater than C. This is the only way, because they cannot be equilateral. We cannot have a situation where A equals B equals C. This is not allowed. We also cannot have isosceles, so we can't have any 2 sides equal to each other, like A equals B or A equals C or B equals C. These are also not allowed. And then the right triangles, we'll worry about that a little bit later. But this is the only way. All 3 digits have to be different. And then from the triangle inequality, we have a rule that A plus B in any triangle has got to be greater than C. The sum of 2 sides must be greater than the third. Otherwise, you can't make a triangle. Now, our perimeter is, of course, the sum of the 3 sides, A plus B plus C. Now, A plus B, this guy right here, is greater than C, according to the triangle inequality. So that means this is greater than C. And then we have to add that C. So what that means is the perimeter is greater than 2C. Okay, so the perimeter is greater than 2c, but it's less than 15. So combining those, we have that the perimeter is less than 15, but it's greater than 2c. Correct? Now, the perimeter is obviously an integer since a, b, and c are integers. So if the perimeter is less than 15, that means the largest possible value for p is 14. So that means 2c has got to be less than 14. Because the largest p can be is 14. It can't be 15. It's got to be less than 15. So if 2c is less than 14, that means c is less than 7. So we have narrowed it down to what I hope will make it easier to calculate all of these triangles. And from the answer choices, there isn't that many, fortunately. All right, so let's make a table, and off we go for A, B, and C. And we only have to worry about C less than 7. So if this is A, this is B, and this is C, we only have to worry about C being less than 7. So let's start with 6. I can have 3 and 5. If I have 6, I can have 2 and 5. And I'm just going up based on the triangle inequality. And let's see what else. 6, 3, and 4, I think that will work. And I think that's it for 6. How about when C is 5, I can have 3 and 4. And 5 will also, 2 and 4 will work. And then I think that's it for 5. And then for C equals 4, 2 and 3. And then once C is less than 4, there's no way of making a triangle with these rules. So we have 6, but it can't be right. So this one, 3, 4, 5, that's a right triangle. So we can't use that one. So we can only use these guys and these guys. So those count up to 5 possible combinations. So number 10, the answer is C.